Okay, cool. We are live. This is Hangops. It's a special Monday Hangops, November 24th, 2014. Uh, going to talk about Kafka in production today. Have a good group of people to talk about that. We'll do some introductions. We'll start off from the left as I see it. Jamie, introduce yourself.
I'm Jamie Alkiza. Work on the ops team at Mandiant FireEye.
Cool. Mike.
Yeah, Mike Hefner. I work on the data and ops teams at Librado.
Paul.
I'm Paul Stack. I work for OpenTable, and I'm one of the infrastructure engineers working on the operations team.
And Todd.
Hey, I'm Todd Polino. I'm one of the Kafka SREs, well, Kafka Zookeeper SREs at LinkedIn.
Cool, awesome. Thank you guys for making some time to talk today. We've talked about Kafka in the past, and we just did a sort of introduction to Kafka food fight show 2 weeks ago with Jay. So definitely, I think the groundwork has been kind of laid for what Kafka is for folks that tune into Hangops regularly. So I thought it'd be kind of interesting to start with you, Todd, at LinkedIn, since LinkedIn is sort of where the genesis of Kafka started. Maybe real quick, talk about the sort of the use case of Kafka, kind of its value, and then go into sort of like what it looks like, in production there.
Sure. So we use Kafka as the backbone for all of our message passing at LinkedIn. So everything that happens on the front end gets eventually flowed back into Hadoop or to other systems for processing, and then some data flows back out again. So we use Kafka both for collecting system metrics, the operating system, the applications, so metrics and logging information, and passing that back for monitoring. We also use it for capturing user information, so what steps the user's taking on the front end, and then passing that back for processing. And that could be for generating internal reports about how many page views and how many times did the user click this particular button, or it could be for taking actual actions like sending out emails is an outbound process, so that comes from Hadoop and goes out. Or user said, oh, I want to add my address book and add all my contacts. So that information comes into one application, gets processed around a little bit, goes to a different application. That message passing happens through Kafka. So we've actually, right now, we're on the order of 70, I think we're around 60 to 70 terabytes per day of data coming into the Kafka pipeline. And all of that is bound for something else, whether it's Hadoop or another application or our monitoring systems.
Yeah. It's just over half a trillion messages every day as well.
Cool. We were kind of interested as you started. And Clark, you want to let people know who you are?
Yep. So I'm Clark Haskins. I'm a SRE at LinkedIn. I work with Todd. Sorry I was a couple minutes late. I'm having internet issues today. So.
Yeah, no problem. And so I know kind of like Kafka sits sort of in a way at the center of the infrastructure. What does that look like on the ground? Is that one cluster per data center? Many clusters? Like how do you move stuff around?
So we break up the data into the type of data that it is. So we have a specific cluster for tracking. We have another cluster for metrics data. We have another cluster for queuing, if it's just being used as a standard queue. And then we have different pipelines, sending data to Hadoop, and those are a set of clusters that are all linked together with mirror makers. Then we have a separate set of clusters that are linked together with mirror makers to push data from Hadoop back up to the production applications.
Okay. And then you guys are all still bare metal with your Kafka stuff, right?
Yep, still bare metal.
Okay.
Yeah, it's pretty important because the amount of disk I/O we do, especially at this level, we really need all the spindles we can get and all the access to the bare metal.
Okay. Interesting. So how do you find yourself sort of like sizing that stuff then?
Sizing the clusters, or?
Yeah, and like disks, and are you doing like a partition per disk and then like a consumer per partition, like kind of that stuff is
So-
talked about in the docs?
Yeah, so we have, typically our configuration is we have 14 disks that are all on a RAID 10, and we give that as one partition to Kafka. And then we have up to 32 of those machines per cluster. 32 is just how big we've gotten so far. They could get bigger in the future. And I think that answers everything you asked.
Yeah, we've got some capacity guidelines that we've been trying to flesh out internally as far as how big do we let a cluster get before we expand the cluster, how big do we let a particular topic or partition get within Kafka before we expand that topic. And some of the numbers are a little bit arbitrary at this point. We've picked nice round numbers around where we start to see problems, and we're in the constantly working on refining it. Like for example, if a topic within Kafka, if the partitions get over 50 gigs on disk, we tend to double the number of partitions for that topic because we don't want them to get larger than that. And that's largely driven on the amount of time it takes to recover that data when a Kafka broker goes offline unexpectedly. The amount of time it takes to reread those log files and load them back up.
Right. Okay. We've also noticed performance degradation within the Kafka brokers themselves if we have more than 4,000 partitions per broker. So we limit ourselves to 4,000 partitions per broker.
Interesting. Wow. Even to me, that seems like a lot of partitions.
Some of our clusters have close to 50,000 partitions right now.
Interesting. And so 50 gigs per partition on disk. So are you doing a hardware RAID?
Yes. So it's actually not a hardware RAID. It's a software RAID with just a fast controller. So. Okay.
Because I thought either in a talk or in the docs at one point, since I started ramping up on Kafka back in like May, I thought there was talk around just JBotting the disks and then sort of like doing a like sizing your partition per disk. It's like, okay, I have 8 disks, I'm going to do 8 partitions as the default. Was that something you did and moved away from, or?
No, we've always run with the RAID 10 config. Okay. I know that it is possible with Kafka to give it multiple data directories, but at LinkedIn we don't actually do that.
Okay. So having the that sort of right, you've got the RAID abstraction. How are you keeping an eye? Like what are you doing in terms of monitoring disk I/O then?
So we have some monitoring around that that we get through different operating system metrics collectors that we have that feed their data into Kafka every minute. But we actually don't have too much alerting around that. We find that we don't actually saturate that too terribly much. What we saturate first is the network. So
okay.
We run with 1 gigabit links today, so we tend to saturate that first. Todd, do you have anything to add?
Yeah, I mean, we especially see that when we're doing stream processing with SAMSA. Other people may be using something like Storm instead, but the stream processing stuff tends to be very hard on the Kafka brokers when it reads, and when a job spins up that wants to bootstrap, it will easily kill the entire Kafka cluster while it's doing that. It's one of the reasons that we've segregated out all of the SAMSA work to its own Kafka cluster.
Right. And as long as you don't have too many consumers that are reading their data from the beginning of time. I mean, in the general case, all of our consumers are caught up, with the exception of SAMSA, because the jobs will start and they'll read all the data that's available. Because they're all caught up, the actual number of reads that go to the disk are very, very few because they generally just hit the page cache.
Okay. Have you found that you have sort of like a global default in terms of like a cluster TTL, or do you find it's more workload dependent in terms of like how long the data lives in Kafka?
For the retention? Yeah, so yeah. We were setting it at 7 days pretty much everywhere, and then recently we reduced that to I think 3 or 4 days depending on the cluster. The idea is that if we have an issue, we'll have enough time to both detect the issue and then move the data along to the consumers before it gets removed.
Okay. So, typically, what are you seeing as a replication factor?
So we run with replication factor of 2 with everything except for the internal Kafka offsets topic, which is set to 3.
Okay. Okay. Interesting. Are you doing any sort of message persistence outside, like Pinterest published that Secure tool for doing archiving to S3, sort of as a disaster recovery?
So we use Camus to pull out all of the tracking data and store it in Hadoop.
Okay.
So that's where it's persisted for a longer period of time.
Okay. But in terms of cluster broker issues, it's just what's on disk with the retention is what you focus on for recovery.
Correct.
Yeah, and we use a local and aggregate structure in our Kafka clusters. So, for example, in our production data center, there is a local Kafka cluster that collects metrics information. And then further back, there's an aggregate cluster where we pull the data from local into aggregate, and we do most of our operations on the aggregate information instead of the local information. So if there's a problem with one data center, we can fail out of that data center over to another, but that's a large operation. If we have a network problem between local and aggregate, there's always retention at the local tier, and then we can restart the mirror makers later to pull the data back into aggregate as we need to, if we need to repopulate data there.
Okay. Makes sense. So what would you say are the key sort of, what are the metrics that you alert around in terms of cluster health?
Pretty much there's 2 of them. There is the number of under-replicated partitions and then the number of offline partitions. Those are really the key into knowing what's going on with the health of the cluster. If you have under-replicated, it generally means that there's a broker down or there's a broker that's slow that's unable to keep up with the rest of the cluster. And at that point, you don't have your replication factor 2. You're in a degraded state at that point, so we alert on that.
Okay.
And offline partitions, of course, that means that something is down and you're losing data.
And given our scale, we actually do watch a few other things. For example, we watch the percentage usage of file descriptors. So we've got our limits set right now to 200,000 file descriptors for Kafka, and if we get over 50%, we know that we've got some sort of problem going on, and we're probably going to lose a broker from that shortly when it goes out of file descriptors. We're also watching the network. We're watching. We have a remote monitor on the Kafka port, so we know when a broker goes offline because the port stops responding.
Yeah.
The big one is under-replicated, though.
Are you so you're doing JMX polling for that stuff then?
Yes.
Yeah, our internal deployment system actually has a very nice container structure. So the container is Jetty that wraps around the Kafka application, and that provides collecting all of the metrics and sending them, unfortunately, into Kafka, at which point they get propagated back to our monitoring system. So we're actually right now standing up a second monitoring system that monitors Kafka without using Kafka.
Right.
We've been bitten a couple times where Kafka will go offline and we'll just go completely blind to a problem.
Have you found you've had to, with sort of dividing broker clusters into different workloads, have you found anything in terms of sizing or, topic configuration that changes depending on size of messaging? It's one thing I found with using RabbitMQ in previous jobs was the size of my messages had a huge impact on CPU usage or RAM usage. I haven't done enough with Kafka to see if there's anything similar. I'm curious if you guys large messages versus small.
So we have noticed some issues with that within Mirror Maker. Obviously, the larger the message is, the more work it's going to have to do to decompress and compress the message. So we have noticed issues there. But we run Kafka with the default of the largest message being allowed as 1 megabyte. And we find that that's actually a relatively safe limit to set. If people need messages larger than that, we recommend that they split them up before they send them to us.
Okay.
So.
Cool. Well, why don't we, kind of just open it up, Paul, Jamie, and Mike, I know all of you are also, running Kafka, at least in part, in AWS. So it'd be kind of interesting to get into that a little bit and how that, changes things compared to, running in a data center.
Sure, I can jump in.
Okay.
I mean, we run on AWS and we're USE, so when we provision our brokers, we're typically splitting them across 3 availability zones. We've been running Kafka for about 2 years now, and I would say it's probably actually in terms of infrastructure, probably one of the most stable aspects of our infrastructure today. So I mean, we watch, in terms of monitoring, we watch the AWS CloudWatch metrics, give you sort of the I/O capacity, the network. We'll compare that with, collect D metrics that we're gathering on the box. And then part of our monitoring, which we monitor, we use, all of our Kafka is used in storm topologies, storm stream processing topologies. So in terms of monitoring storm, part of that is also, we hit the MX4J port on Kafka to get the byte offsets and some of the memory statistics from the JVM from that.
Okay. And so you guys are kind of in an interesting workload in that you're hosted metrics storage.
We are, yeah. So we are real-time monitoring metrics and alerting. So, the primary use cases we have Kafka for are roll-up aggregation. So taking the raw data, generating those longer retention roll-up samples, and also for aggregation across tiers. So if you're sending data in, from multiple worker nodes that are all like working on some aggregate metric, number of jobs processed, you actually send in aggregates. We'll sum those up and give you a single metric tracking, that work across a scale-out tier. So we push all of that into Kafka, and then via a number of different storm topologies, aggregate that data over time and push that back into our at-rest data storage. And then additionally to that, we also push all of the data through our alerting topologies. So depending on whether you're doing like a moving window alert or you're looking for, we have the ability to alert if a sample goes away. So we're pushing all of our sample data through the alerting topologies as well that track in-state, data on whether the moving average is above or below some threshold, or a source has disappeared.
Okay. What are you doing? Well, a couple things. One, instance sizing. I'm curious about that, but then also, like we were talking about with Todd Chuck a minute ago, like, are you doing anything internally around like chunking messages to a certain like size that you found gets you throughput, sort of a thing? Like, the data you have, do you like break it down into like smaller chunks or something just to maintain performance or something?
Sure, actually, so we have, in terms of instance sizing, we found that, largely it's dependent on how much disk space we can get on the nodes. So we are, we don't use EBS at all, so we're primarily based on the ephemeral storage. We'll take the ephemeral drives and do a RAID 0 across, both the drives in this case on the nodes that we're using. So the nodes we have today have, I think, about 1.4 tera per node in terms of disk space. And we started with a 10-day retention, and I believe we've taken that down to about 36 hours, largely just to manage the disk capacity that we have on those nodes. In terms of like serialization formats, most of our messages are pretty small. It's a small JSON blob of epoch time, value, metric name, and we found that actually for us the primary we've been moving to protocol buffers for that, primarily actually for the fact that it reduces our processing on our actual stream processing tiers in terms of the amount of like time to deserialize, serialize, back and forth from JSON versus like a protobuf format. But that also saved about 60% on terms of our message size, so that was an added benefit.
Interesting.
Um,
So,
terms,
oh, go ahead.
I was going to say, actually, in terms of operationally, one thing we did track down was we use the XFS file system for most of our storage. And for a while, for XFS, you can define the allocation size that it pre-allocates for files that you are writing in append-only mode. And by default, it will fall back to sort of an exponential pre-allocation scheme. So our Kafka log size format was about 500 megs. So for each of our log segments on disk, we were holding about 500 megs pre-allocated in the XFS file system. So we actually were running out of disk space a lot sooner than the on-disk files would have led us to indicate. So one thing we did track down was mounting the XFS partitions with an alloc size of, a fixed size like 16 meg. Is what we're using today. Helps sort of reduce disk usage, just in how the sort of Kafka write load looks.
Cool. Now, Jamie, you recently did a post on load testing Kafka in AWS, right? That was like a month ago that came out?
Yeah, roughly. Yeah.
You want to kind of talk to that a little bit, and then just kind of talk about what you're doing with Kafka, your environment in general, what you can.
Yeah, and to some degree, I'll have to be a little vague. I mean, we're like a security company, and some of the ways we're using it, I'm not sure if I'm really supposed to be saying it, but anyway, we have several. I'll kind of just refer to it as like our event pipeline. So we have lots of messages going through an event pipeline. It's got a lot of in-house custom services that we wrote. We actually use several different queuing services. We recently just started using Kafka, so actually my experience in using it in production is a little limited. I think around the time that I wrote that blog post, it was kind of going through like a typical phase when we introduce new services like this. One of the first things we do is after just like tearing up all the docs, I do a lot of tests based on some of the ways we expect to use it. So we have I'm trying to think of a good way to put this. So we have a lot of environments where we're sending a certain amount of events per second and at a roughly kind of like consistent size. So I reference like 2.5 to like 3 kilobyte message sizes. These event rates can be several thousand for like our dev environments to 20, 50, 80,000 in some of our production environments. For each one of them, we're actually running a separate Kafka cluster, and there's actually a lot of reasons for that. So a lot of the initial testing I did was to kind of get some baseline expectations of instance sizes based on some of these known event rates. So if you actually reference some of the things we talked about, like event sizes, I did a lot of tests where I would start with like really small event sizes, and I noticed that it seemed like the primary bottleneck if you're waiting for ACKs is like early on you'll actually burn a lot of CPU on ACKs, it seems. I mean, I didn't like extensively profile the app or anything. Larger event sizes, kind of like previously mentioned, it's really easy to just saturate the network. I think one thing interesting that we are doing is we are using EBS. Strictly the general purpose SSD though, and I'm only using them in pretty large stripes. I guess one thing on that kind of dictates our instance sizing is, I don't know if it's still true with the recent announcements of changes to EBS, but I actually don't use anything larger than the R3 4XL. There was a period, I think, where the EBS channel was the same size on the 4XL as the 8XL. So that was a big factor, because if you could saturate a 4XL on storage throughput, you're not going to gain anything by going to an 8XL unless you actually needed the memory and CPU, and I didn't find that being the case. Trying to think what else. Another thing is we use very short retention. We are right now defaulting to only 4 hours, and the reason for that is, like I mentioned, we actually have another queue in our pipeline. When we have like bad things happen, we have a way to actually kind of build up our events into a separate queue, and we still rely on that. And part of the reason I put a very short retention on Kafka was that it makes it much more predictable. kind of like mentioned, if you go and fetch really old messages, like let's say you have a 7-day retention, it's very easy to destroy a Kafka cluster. If you have many consumers just go back and fetch like the full 7 days, you could just destroy it. So there's several attributes to our application where if you have to fetch more than 4 hours back of events, like something really bad is happening. So I kind of use it as a constraint right up front to really limit how much damage you could do to a Kafka cluster. If that makes sense.
Yeah, no, that's interesting way to kind of create an SLA around it in terms of like UX. How I guess I'll put this question to sort of to you and Mike and Paul, since I know you're all doing some in AWS. And there's the biggest like instances could go in any time, but how have you had any like EC2 instance failures, and how has your cluster handled sort of like a broker failure? We haven't really had any broker failures yet, machine death that caused a broker failure yet.
So far only manually, because like I was saying, it's kind of like in an early stage in terms of making it into being a standard component in our software stack. So the most I've done is kind of in some of the tests I've arranged. We'll just kind of saturate the brokers and kill one of them, kind of see how it behaves. I know that in particular is going to be something more heavily stressed by our QA team, which is I think something kind of actively going on right now, but no just like natural EC2 failures. I mean, surprisingly, we actually don't have too many. I mean, we kind of lean on US West 2. I don't know if it's like the lucky location or something, but I mean, if like trying to think out of like every maybe like 1,500 EC2 instances, I maybe see like 1 or 2 a month just get stuck where it's kind of like those planned deaths, right? Where the hypervisor is having hardware issues and they send you a notification and you've got to start stop. I mean that's the average that I see.
Yeah, I wouldn't say we see a lot of failures. I mean, most of our data set we can actually replay from our on-disk storage. So if we have issues with the stream processing tier, we can go back and fire up a batch job to actually just read and reaggregate, et cetera, that data that went missing.
Okay. Cool. Paul, you want to talk a little bit about like your workload, what you're doing with Kafka?
Sure. So we're probably the smallest user of Kafka. We use it primarily for logging. We used to have a Redis input for Logstash and then do Redis to Redis brokering and then into Elasticsearch. We actually found that our message throughput was just too much for Redis to handle. So because we were just filling up large amounts of RAM and boxes, so we decided that we would put Kafka in place and we would have Logstash outputting messages to Kafka, and then Logstash pulling messages from Kafka into Elasticsearch. We run in 5 AWS regions, so we try to keep our message queues, our message clusters, very close to where people are actually running their instances. And then we use the mirror maker process. We go cross AWS regions, and our main Kafka cluster is inside US West 1. Yes, currently US West 1, going to be moving to US West 2 because it's got some space constraints there right now. So we only have a 7-day retention policy on our Kafka cluster, but we're in the same situation. We haven't really found that having EC2 instances have been too much of a problem for us, because it only tends to be when, as was mentioned before, some hardware planned maintenance is coming up and we can just start and stop the nodes. And because we don't use EBS, it's not too much of a problem. We use the ephemerals, so we use M1 XLs. So we just have a small 1.6 terabyte disk on each of our Kafka instances.
Interesting. So one of the things I think it was Todd, you mentioned it was you sort of like a 50 gig partition sort of upper end. I'm curious, how are you monitoring like partition disk usage? Sort of a general question, but how are folks keeping track of like how big partitions are on disk?
So it's one of the metrics that we're emitting from Kafka using the containers. We're collecting information about the partition sizes through Kafka's sensors and then sending them into our monitoring system so that we can keep an eye on them there. That's also where we're viewing the partition counts. So primarily, that's what we're doing. The process of actually checking whether or not the size is exceeding 50 gigs is mostly manual right now. While we have an automated alerting system, obviously, turning on the per partition monitor for every single partition as to whether or not it's over 50 gigs actually overwhelms that system because of the number of partitions we have. So we run a job periodically to check and see which ones are over that number and which ones are under, and then adjust them, about once a week or so. Once we get some capacity set up around our own monitoring system, we'll be able to turn that on in across the board. But right now we're talking about 190,000 partitions that we have to monitor.
Right. So is that exposed via JMX, or is it something custom that you're able to get out?
No, it's part of the JMX that's exposed. And as I said, the Jetty container that we wrap around Kafka as part of our internal deployment system has annotations as to which JMX MBeans get picked up and sent into our monitoring system. So that's available in Kafka's JMX now.
Cool. I'll have to look through that. I didn't notice that was one that was available. What I've done for us for metrics is I'm using JMX trans, and mostly what we're pulling in is the the byte and request and message rates and the various time aggregations. And we mostly tend to look at the 1 minute counts. So it's sort of per topic.
So that's interesting. We actually go directly to Zookeeper for all of our metrics, and we plot all of our metrics into Graphite, and that we can see right down to primarily our problem at OpenTable is that we get a lot of lag because we're going cross AWS data center and outside of our own data centers as well, and we actually want to monitor the lags on a partition by partition basis, and being able to see that information directly via Graphite was actually pretty useful for us.
Yeah, we do something similar where we're pulling the consumer offsets for certain key topics and consumers out of both Zookeeper and Kafka, and then calculating the lag and sending it into our monitoring system as well.
Right. It's helped us actually identify some errors in the past couple of weeks, and we actually found something really strange, that we were logging only to one specific partition for almost 10 minutes at a time, and we actually had to. We went and had a look at some code, and it was a previous version of Kafka that we were looking at, and it wasn't assigning a random ID. And as soon as we actually made a fix to that, it started being a lot smoother, and our lag dropped by millions of messages a day.
Yeah.
Nice.
Yeah, I did
Go ahead.
some Ruby code that right now just runs as a cron job on one of the Kafka brokers, where it uses one of the CLI tools to get the current offsets of the partitions, and then compares that with the offsets that Kafka spouts with Storm or storing in Zookeeper, and then emits each value, and then does some math to determine the lag of the two offsets, and emits all those into Graphite. But I made a little dashboard that's just the all topic messages in per second 1 minute rate, and then per topic, just sort of to see kind of what's my throughput. But we also use per topic 1 minute message rate, and compare that with we have different applications that are, when every time they're putting a message into Kafka and reading it out right on both sides, they're also putting those into Graphite. So you can sort of compare what does the app see, what does a processor see, and what does Kafka see, and if there's a huge difference in them, or if one part just sort of doing some basic diff series. So, one of the things that I feel like catches a lot of people by surprise when they go to look at Kafka, especially if they're coming from like maybe Rabbit or ActiveMQ, is the Zookeeper thing. What's this? Why do I have to run it? So why don't talk about that a little bit? Sort of like this the production side of Zookeeper.
Okay, so at LinkedIn, we run our Zookeeper with a 5 nodes per cluster, and we also put them on SSDs. And if you look online, there's a lot of mentioning about not running them on SSDs. And we've had them running on SSDs for almost a year now with no problems. And it was actually great for us because it reduced our average latency per request to 0 milliseconds. So previously it was between 10 and 20 milliseconds per request, and now it's literally 0. So that drastically improved the amount of time it takes consumers to rebalance, and a bunch of other things within Kafka. So
why 5 and not just 3?
Because this way we can do maintenance on the cluster. If we have a node down, we can actually take a 2-node failure before we really have anything to worry about.
What sort of instance sizes do you run as your Zookeeper instances?
What do you mean?
So like, is it lots of RAM, high RAM, high CPU, or is it pretty minimal boxes?
So ours, they're on bare metal, and it's a 64 gig machine. I don't remember the rest of the specs. Todd, do you have them?
They're 12 CPU so they're essentially 24 CPU boxes. I think they're 2 gigahertz or 2.2. So they're our standard application node that we use for most applications internally. It's just a standard config that we have that everyone uses.
And it's 24 cores, not 24 nodes.
Yeah.
What do you find the limiting resource is on like Zookeeper for Kafka?
The biggest limit was, just the write to disk. But since we moved to SSDs, that hasn't been a problem. And honestly, we haven't really worried about Zookeeper much at all since. We do run Zookeeper for lots of other applications within LinkedIn, and so we run about 5 or 6 different clusters with different purposes in each data center. And the only issue we ever have is we saturate the network outbound. But that's due to a misconfigured application more than anything else. So,
how big of a heap are you giving Zookeeper with all that
I
RAM?
think it's a 2 gig heap.
Okay.
Is that right?
Yeah, we're running 2 gig heaps, and I mean the heap size on Zookeeper obviously is really just driving the amount of data you can store in Zookeeper. So we don't even get close to that.
Okay. Yeah, because right now we've just been using M3 mediums, which is like a 4 gig of RAM. It's not a big one, and Zookeeper, but it's got a 4 gig SSD, which is where we put the snapshot and the transaction directories, and it's only for Kafka, so it's like ridiculously silent.
Right.
So
Yeah. We generally find that Zookeeper is just fire and forget. For the most part, we barely know it's there. We barely have to worry about it except when we're doing maintenance.
Right. And our boxes are drastically oversized for what we're using them for. It's just that's our standard node. That's the smallest we can get. So.
Okay, that makes sense.
We use M3 mediums as well, but we do something slightly different. We don't actually manage Zookeeper ourselves. We let Exhibitor manage Zookeeper for us, and we have actually puppetized Exhibitor, and it just keeps our Zookeeper instances alive and talking to each other and manages the configuration.
Nice.
Have you been pretty happy with that then?
Yes, and for the most, yes. We found that was an easier option to go. Zookeeper Exhibitor is just a simple UI across the top, right? But the fact that it manages it for us as well just meant that it was just an added bonus, and we didn't have to worry about duplicating configuration in different places.
Are you using the S3 backend for the configs?
We're actually not. We're just using EBS storage.
So you're doing the file config for Exhibitor? Okay.
Yes.
Because we were trying to do that with Chef and the file configs, and I found Exhibitor would get into weird states, and we ended up just yanking it out, and I haven't really gotten back to like trying to reintegrate it.
I have to say it's it's been pretty simple to start with for us, but they're pretty small nodes. You know, they're M3 mediums. They don't take a huge amount of messages a day through them. But when we start to scale up, we may find other issues that we're just not aware of yet.
Is anyone doing anything in terms of like exhibitor backups? Like, you know, shoving the directories on S3, or I've seen a couple different tools that act like ephemeral nodes and suck everything down. No?
We don't back up our exhibitor stuff at all. We've just started pushing our Kafka messages into S3 using Secure, and we've just written a small parson, a few small commits across the top of that in order to actually break it down into log/stash message type. So for us, each application has its own type and its own specific fields that it needs. So we want to be able to store a single day's worth of logs for a single application in S3.
Interesting. I think I said exhibitor, but I meant Zookeeper data. But, you know, same thing.
So, if you were talking about Zookeeper, we are in the process of setting up observer nodes to kind of act as a backup for our existing Zookeeper. So we'll pull that data out using the observer and offline it somewhere else.
Yeah, that's kind of what I was looking at. I think it was Boundary has a tool that like hooks up like that and just like basically like on a schedule it'll suck everything down. I was thinking about just rolling that up into like S3 as, you know, like a bucket per day, or not a bucket, but, you know, a folder per day in a bucket or something.
Yeah, we use that. Oh, sorry. I was going to say we used that once to move a staging cluster for Zookeeper and worked well. The Boundary tool.
Oh. Interesting question from Twitter. If anyone is using Kafka with something besides Zookeeper, like console. I don't think that's possible today, is it?
Not that I'm aware.
Yeah. So I know you guys are focused on the operational side, but I would imagine you guys keep a good eye on and probably drive a lot of what's coming in new releases. 8.2 is in beta, and I know there's planning around 9. That's something you could talk to at all, like anything you're looking forward to with like 8.2, or maybe you're already using, and then also with 9, I know there's stuff around like a lot of security features seem to be one of the focuses of planning for 9, 0.9.
I know, you know, specifically we're still actually on 0.7, so I'd be curious in this group, you know, if, you know, guys are using 0.7 or 0.8.
We're running 0.8. One of the build it's about a month old now. That's what we have running in production. So
Yeah.
off the trunk.
Yeah, about a month old off of trunk is what we're trying to say. So we're a little behind because we've had a few issues that we've been dealing with left and right. But some of the features that are pretty nice are things like, you know, the Kafka offset storage is actually much better than the Zookeeper storage and works pretty well. There's a little bit of tooling lacking around it still, but it's all coming. The developers have been working on filling in those tooling gaps.
So I think one of the goals for 0.8.2, once it hits stable, was the topic deletion being considered baked. I don't know.
Yeah. Delete topic's been a pretty interesting one. That one got put in at our request, and it wasn't fully tested, and it broke, and then it was pulled out, and now it's been put back in. And the last time we tested it, I think it wasn't quite working properly. There were a couple issues with it. One of our developers has been looking at it internally and trying to work with the 0.8.2 release to make sure that it's clean for coming out. We have not tested it again internally. We actually just went through our staging clusters over the past few weeks and did some topic pruning by shutting down the entire cluster, clearing the old topics by hand, and then restarting the cluster.
Okay.
Yeah, we had to do exactly that same process, and one of the biggest things we were saying internally was, wouldn't it be great if topic deletion was included in the next release?
We have our fingers crossed.
We're really hoping it works this time. Because honestly, the only clusters that we can take an outage on are the staging clusters, and even that hurts our development customers a lot.
So I, just due to lack of time, don't even really pay much attention to like what's going on in trunk and development and stuff. Is any of the stuff around like ACLs and like I think there was some talk about SASL integration. Is any of that stuff being worked on, or anything that you guys are using any form of, like authentication stuff or like encryption in flight, anything like that?
We're not using it internally, but it is something that is being worked on. There's actually an effort within the Kafka development community on the open source side to add the security features, including ACLs, authentication, encryption, both SSL, TLS, and some sort, looking at encryption on disk as well. We're also looking internally at adding Zookeeper ACLs on top of that. Since we don't really use any right now, it's pretty wide open, especially since we have so many consumers that are touching Zookeeper. But that's all happening on the open source side and not specifically within LinkedIn.
Okay. Do you do anything internally with other tools to do any sort of like encryption in flight or at rest, or is it like you sort of assume other security surface areas are sufficient?
In general, we leave that to the producers and consumers to work out. So if somebody wants to encrypt their data, if they want to put PII into Kafka, for example, they need to take care of the encryption on their end before they send the message in.
Okay. Yeah, that's kind of the approach that we've taken, because we deal with a lot of PII, stuff with dealing with phone data. Cool. We're getting about to the top of the hour. Try to keep this to an hour. I thought it might be interesting to just touch on some of the more trickier parts of the operating, like adding new brokers, rebalancing leaders, rebalancing partitions, partition reassignment, that stuff. I've been trying to idle in the Apache Kafka channel on Freenode for a few months, and I feel like a pretty common topic is, why doesn't the partition reassignment tool, why can't it be smart? Why can't I just feed it a list of brokers and it does all the magic for me? And I've done that manually, like sort of the manual rebalancing on a couple of clusters that were like staging, but then they got built and the defaults were just 1 and 1, and we wanted them like replication of 3, partition of 8. So I built all the JSON by hand, and it was kind of like, yeah, this is kind of a pain. I could see why it'd be nice if maybe there was just some Scala that did it for you.
So this is an interesting topic. So internally at LinkedIn, I've written 4 or 5 different scripts to move partitions around the cluster, and they all do things slightly different. So one of them, it looks at the total size on disk and tries to make that balanced across every single broker. Another one looks at the total number of partitions per broker and tries to even that out. I wrote one recently, a couple weeks ago, that looks at the rack information to determine which rack a Kafka broker is in, to ensure that the replicas for the partitions are not in that same rack, so that in the event of a catastrophic rack failure, Kafka is not really impacted by that. So I think one of the reasons that it's left to why the partition reassignment tool is so dumb, if you will, is to allow us to build the tools to do it however we need, and we've really taken advantage of that at LinkedIn, and we're looking to open source a lot of these scripts.
So are they actually like single one-off scripts, or are these like the same style of scripts that you would run again and again, and will eventually create like a tool, some sort of tool or a platform run for you guys internally? So
a lot of the code is shared among the scripts, and so ideally it'll be one script, you give it a bunch of different options, how you want to balance it, if it's by size or by number of partitions. So that's the end goal. So. Then the other thing we want to do is we're working with the Kafka devs at LinkedIn to try and get the rack locality information built into Kafka, so that when it creates new partitions for topics, it assigns them appropriately to the correct broker.
Would that just be like through a config property that you maybe
Yeah,
set?
so we're thinking it would be through a config property that, just an additional attribute for the broker that tells it which recovery domain or failure domain that it's in, so that it ensures that the replicas exist somewhere else.
Interesting. Cool. No, that makes sense. And I think that is kind of hard to like make a general purpose tool, but I think it sounds like some of the stuff that you've identified, like number of partitions, size on disk, like you could put out some sort of simple heuristic based stuff, and I think that would be really cool to see. One handy little script that I found that I still got to get into our like wrapper chef cookbook to get put on all our clusters, but it is a shell script from the folks over at Wikimedia that they actually found in the repo that has all the code for building Debian.debs. They have a little like deb repo for building Kafka debs, and it's a shell script that gives you kind of like more of like a REPL kind of experience for all of the stuff that's in bin. So it's all like 2 or 3 name hyphen separated commands. And I was just curious if anyone else has found any like utilities or anything that like has helped them operate Kafka easier. Or any scripts you've written, like any like, oh, this was a missing piece I wrote.
We haven't used anything quite like that, but we're thinking of putting like a Zookeeper instance on our Hubot boxes so that we can start to query our Zookeeper setups and our Kafka setups and our mirror setups directly from our HipChat channel. I'm lazy. I like to do things on my phone.
Okay, cool. Well, I'm out of questions. Did anyone have any questions they wanted to ask of the panel?
I had one particular question around consumers of Kafka. So we're right now internally we're trying to understand what people want from our data. So we have data sciences, we have data analytics, we have different development teams, etc., etc. And we sort of right now want to control the consumers so that we can understand the effects that the consumers have on our cluster because of the amount of data that they're pulling it. Has there been any understanding of instance size or partitions, etc., or days retention against the number of consumers before a Kafka cluster will fall over?
We've actually got one internal consumer who is not the best designed consumer. The data gets written into Kafka once, and their one consumer pulls the data out 60 times. And each of those 60 groups that are pulling an entire copy of the data only keeps 1/60th of the data. So they filter through and find the messages that they want and throw out everything else. So when one byte written in translates to 60 bytes getting read out at any given point. We're trying to work with them on a better design. But in general, we try not to, as operations, we try not to care about what's being produced and consumed as far as the data goes. Unless a consumer or producer is being badly behaved, and then we go find them and work with them to make sure that they're not doing bad things, we don't care about the data that's flowing through the system. That's the contract between the producers and the consumers is they're using Avro encoding on the data, and we have a schema registry so that if you want to decode a particular topic's data, you go and pull the schema from the schema registry and have at it use the data. Other than that, we're hands-off. We're just providing Kafka as a service.
But one thing you should keep in mind is the ratio between the number of writes in to the number of reads out, so that you can size your clusters accordingly. So you do need to keep track of the network bandwidth going out of the cluster, so you're not completely saturated.
Have you had any issues in tuning like the JVM like garbage collection on Kafka? Has that ever been really a pain point?
It has. Todd, do you want to talk about that?
Yeah, I mean, we used to do a lot. There was a lot more tuning. I mean, we had been previously running on CMS and Parnu, and there was a little bit of magic in the tuning there that seemed to work properly. Since we've switched to JDK7, we stepped up to using the G1 collector pretty quickly, and G1's been working very well as far as the Kafka brokers go. The only thing we've done is we've set the pause time target to 20 milliseconds across the board for Kafka, and it has run without a problem in both JDK7 and JDK8 using G1. The place that we've had a few more problems with the garbage collection is in the mirror makers. Because they do so much decompression and recompression of the data, some of our mirror makers were doing huge allocations within G1, and we're actually causing G1 to not work properly until we changed the block size for G1 to make sure that most of the allocations were not humongous allocations. That's really been the biggest garbage collection problem we've run into.
And what compression do you run, actually? That's interesting.
It's all gzip compression internally.
Okay. So we're trying out Snappy right now, and it seems to be quite nice.
Cool. All right. Well, seems like a good place to wrap it up. Unless anyone had anything else. Well, thanks everybody for your time. This was awesome. It's definitely super educational for me and timely too. I'm working on an intro to Kafka blog post for sysadvent, and in theory was going to do a Kafka and AWS sizing one for AWS Advent. So I've got some between the JCreps podcast I did a couple weeks ago and this, I've got a lot of material to translate into a blog post. So, but no, it's really useful, and I think a lot of people are going to get a lot out of sort of hearing about this in production, because I think it's still a new, relatively newcomer to a lot of folks, and especially in the web space, running JVM stuff is still sort of like, there's a lot of like. It just seems like a different world to a lot of, like, I think web ops that were more of the lampish sort of stacks. So I think hearing about it, and hopefully hearing that it's solid. It's been one, the Zookeeper Kafka combo has been one of my favorite things to be on call for, because it just doesn't ever page, really. It's like disks filling up from log files being in the wrong partition has really been the issue I've seen a couple times. So cool. Well, thanks everyone, and have a happy holidays for those of you in the U.S. this week, and we'll be back next week on Friday.
Thanks, guys.
Thanks, guys.
Thanks for doing this.